All right, guys. So today we're going to do some optimization problems. It's 4.5. And optimization is really just trying to find the most efficient way to do something, whether that's, maximizing your dimensions to give you the most um, volume, or maximizing profits, or doing anything like the most efficient way. One thing I really like to do and talk about at this time is something like this with water bottles. If you notice, water bottles um, are often this like conical shape, and you're thinking, oh, it's because they can fit into cup holders, right? The answer is yes, but it's also because they want to create the most amount of volume with the least amount of um, like surface area. So they want to maximize the volume while keeping the surface area to a minimum. Because if they can keep the surface area to a minimum, then it's less materials, their overhead's lower, and so that they can take this and say, okay, well, I can, create this one I think is only what, 20 ounce, 24 ounce water bottle with least amount of materials, whereas this one has more materials because it has a handle and all these different things. So, to be honest with you, that's why you don't see like rectangular water bottles because a cylinder is way more efficient in that manner. The most efficient is a sphere. So a spherical water bottle, the only problem is that you have to have a be able to like hold on to it, right? And to fit into cup holders. So that being said, one day maybe we'll have spherical water bottles. But today's not that day. So we're not going to do that optimization problem. We're going to do a different one. And to like kind of just tell you, like introduce what optimization is we're going to come with this problem right here. If I want to know what two integers, x and y, that add up to 20 will have the greatest product. So I want to say, okay, well, so I can, start listing them out. Well, I can do 1 and 19, which if I multiply them, I get 19. I add up to get 20. I multiply to get 19. Well, 2 and 18, I'm going to get 36. 3 and 17. You guys get the idea right here, right? 51. 4 and 16. 64. And so like, okay, well, which one is it going to be, right? And so one way that we can do this is we could say, okay, well, I'm going to find out, hey, I want to know the greatest product. So the product is going to be equal to x times y. Greatest here is going to be a maximum. Now, in order to find maximums, I need to find critical points, which is where the derivative is equal to 0. Okay? So I can say, well, x and y is kind of gross. I have a p, I have an x, I have a y. But because of this function right here, I could say, hey, well, y is actually just 20 minus x. So my product then is going to become x times 20 minus x, which then is just 20x minus x squared. And that's going to be my product. So if I want to take the derivative then, I want to know where this derivative is 0. I get 20 minus 2x, and I want to know where the derivative is equal to 0. So I get negative 2x equals negative 20, or x equals 10. So an x equals 10 is going to be a critical point. So I can plug it back in and say, okay, well, what's going on here? Well, I can take the second derivative, p prime double prime is equal to negative 2. Well, if it's equal to negative 2 at all points, that means that everything here is going to be concave down. So that means it has to be a maximum. So I know, without even graphing this, that x equals 10. Sorry, I'm going to go ahead and try to erase that right there. Is my maximum value that it can be. So if I go over here and I do 10 plus 10, I'm going to get 100. I'm like, well, how do I know it's that way? Well, because of our derivative and our second derivative, it tells us that this is the maximum value between 0 and 20. And because it's the only critical point in between, well, for the whole function, right? And I know it's concave down, so therefore that's an absolute maximum. There's nothing that can be bigger that will give us a bigger product. And to kind of show you this, I'm going to say, hey, look, here's the graph. It looks like this. So you added them up and when you multiply them, you get to right here when x is 10, we get our product is 100, which is our maximum. So it looks like that. So the optimization problems that you're going to be doing are going to be very similar to something like this, but it's going to have more of a contextual basis. You just have to find what we're going to do when you solve these is you're just going to, make sure you read the problem, identify the variables, and organize the given information with a picture. Just like related rates. Like honestly, it's like, oh, I should organize everything I have and figure out what to do with it, just like related rates. And we're spending so much time on related rates because it's going to help us with the optimization stuff later on. Okay, you want to identify that what are we even trying to do? The objective function. Okay, the function to be optimized. In this case, over here, the function we wanted to be optimized was this product function right here. This was the one that we thought was the most important right there. So identify constraints, write them in terms of the variables of the problem, use the constraints to eliminate all but one independent variable, and then you can find the interval of interest. Okay, use method of calculus to find absolute maximum minimum. That's taking the derivative, taking the second derivative to find out if it's a max or min. If necessary, you can check the endpoints. Because, if this was like a parabola that's opening up, then those endpoints would have been my maximum values. But it wasn't, so that's not the case. So that's all optimization is. Classwork is going to be critical in here because you're going to see what kind of problems are they actually doing. And I could sit here and I could show you examples and show you examples, but really you engaging with them and getting familiar with them with each other is going to be the most important thing. For my online people, work through the problems that you see them working through in class together and see if you can't get similar things. Try to work them out. The homework for this one should be a little bit simpler. Well, I'm getting a little bit smaller with the amount of problems, but it might take you a while to do it because the problems are going to be pretty intense. All right, so that's it for this video, and we'll see you on the next one.